Delivery guarantees. What do you mean by delivery guarantees in terms of multiple channels? Flume is using transactions to ensure the batch of events is reliably delivered from source to a channel and from channel to a sink, right? So in case of multiple agents, already we have discussed about delivery guarantees between source, channel and sink. Now what happens when I have multiple agents? Just go through this one. From the source, it is coming on to channel. From channel, it is going on to next agent. From there, it is using this channel, and from there, it is going on to sink. So there could be a failure at any point of time. How do I ensure the delivery? Or how are we ensuring, or how are we guaranteeing the delivery of events from the source to the sink? Flume uses transactions, as we have mentioned. The operation to read a batch of events from the file channel in agent 1 by the Avro sync will be wrapped in a transaction. What is the meaning of this one? From this file channel, whatever you are trying to receive, this Avro sync will try to put them into as a single transaction, right? The transaction will only be committed once Avro sync has received confirmation that the write to the Avro source remote procedure call endpoint was successful. What is the meaning of this one? So this Avro sync is trying to commit the transactions because I have got a source 1 acknowledgement. I have passed on all the event information to the sync. So first level sync here. So it is trying to commit the transaction. This confirmation will only be sent once agent 2's transaction wrapping the operation to write a batch of events to its file channel has been successfully committed. What does that mean? So this sync says I have committed the transactions, all the changes are successful when it has passed on the information to the next level source, and from there it has gone to file channel, and there is no problem till all the events have reached file channel. Then only it will try to say the transaction is complete, committed, right? Anywhere if there is a problem at agent 1 level, it will solve it in one way. If there is a problem with agent 2, it will solve it the other way. We will see now. This confirmation will only be sent once agent 2's transaction wrapping the operation to write the batch of events. Thus, Avro sync source pair guarantees that an event is delivered from one Flume agent's channel to another Flume agent's channel. So, from this channel, from this sync to the source, the data has reached properly, then only the commit will be issued. Now, the situation, if either agent is not running, agent 1 is not running or agent 2 is not running, then clearly events cannot be delivered to the final sync. So, for example, suppose agent 1 stops running. Where is agent 1? Here is the agent 1 and this has stopped running. In such case, what happens? Where is the problem? If agent 1 stops running, then files will accumulate in the spooling directory to be processed once agent 1 starts up again. Also, any events in an agent's own file channel at the point the agent stopped running will be available on restart due to the durability guarantee that file channel provides. What is the meaning of this sentence? Try to understand. The problem is with agent 1 has failed. What is the meaning of agent 1 has failed? Agent 1 has failed. The chances could be the source has given all the data to file channel, but the file channel was full. It could not pass on the information to the sync. Somewhere the issue is with the file channel or with passing on to the sync. So in such case, say for example, the spooling directory has given all its event to file channel. The file channel will try to save them in its memory until this transfer link is up. Say for example, this transfer link itself failed. In such case, the operation, there is no much loss here, because at the source side only I have the failure. So here itself I will take care of restarting the transaction. But the data has reached the file channel, but it has failed. In such case, the file channel will hold all the information until it reaches the sink. Say for example, the problem is not with agent 1, but agent 2 stopped running. What will happen? Then events will be stored in agent 1's file channel until agent 2 starts again. However, channels necessarily have a limited capacity, right? Say for example, I am trying to pump in some 500 events, whereas suppose the channel can hold only 300 events. What will happen to the remaining 200 events until agent 2 is up again? In such case, what will happen is the file channel will not recover more than 1 million events. 500, 300 is just an example to give you more meaningful understanding. In reality, the file channel will not recover more than 1 million events. So what is the capacity of a file channel? By default, it will hold 1 million events. So if there is any failure with agent 2, the file channel can hold them. If there is a problem with file channel itself, it will try to recover 1 million events. And it will stop accepting events if the free disk space for checkpoint is beyond 500 MB. These are the default parameters which can be configured. So in all these scenarios, if agent 1 doesn't recover, what will happen? The loss is limited towards the events at the source side only. So in the entire architecture with multiple first tier architectures, if you try to see this diagram, say for example, I have multiple tier 1 agents. If one of the tier 1 agent is failing, what it will do? First we will try to recover. In case of it is taking much time to recover, the load balancing concept will come. Other tier 1 agents will try to share the load and will try to complete the transaction. Graceful degradation. So they try to follow this. So just go through this. If agent 1 doesn't recover, then the loss is limited to the events in its file channel, and because they are not delivered to agent 2. So for example, whenever you are having tier 1 agents, one of the agent is failing, other tier 1 agents can share, and if the nodes are running load balanced web servers, then other nodes will absorb the rest of the share. Now, an unrecoverable agent to failure is more serious. Agent 1 has generated the events and it is holding it in file channel, but agent 2 is never up. In such case, what will happen? Again, any events in the channels of upstream first tier agents will be lost, and all the new events generated by these agents will not be delivered. The solution to this problem is for agent 1 to have multiple redundant Avro sinks arranged in a sink group. What is the meaning of this one? If you observe this diagram, there is only one single sink which is also having a limited space. So in such case, instead of starting the entire event group again, what they are suggesting is go for a sink group. What do I mean by sink group? We will just see a batch of sinks will be given which will try to hold the information just to have multiple memory locations. It's like providing multiple buffers which can store the information until some other device which has failed is up again. So what are sink groups? Just see this one. A sink group allows multiple sinks to be treated as one for failover or load balancing purpose, and if a second tier agent is unavailable, then events will be sent to the sink group, one of the sink groups. So just I will show you this one. So just go through this one. How do we configure the sync groups? Multiple syncs, intermediate multiple syncs, not the final sync, intermediary multiple syncs will be there who will store the events and they will wait until the agents are up again in case of failures and load balancing. So we are trying to configure them. How many sync groups I am defining? Previously we were specifying multiple syncs. Now what is the different property? Sync group. Both these syncs are acting as the intermediary syncs which are trying to hold the information in case of a failure or in case of load balancing. So multiple components that are available on Flume. So I am just specifying a list what are all the components we have. Have a look at them. So in practicality, we might be using all these things wherever the organization works on Hadoop framework. So multiple components.